Hi, this tutorial is going to take a look at our one sample hypothesis test Excel calculator, and it should look familiar because we have a separate video on confidence intervals that we did using these same data and examples. And so now what we're doing is we're building on what we learned from studying confidence intervals to put this in a formal hypothesis test. And with that, being a little more precise in our calculation of position, right, relative to between a sample and a population. Um, so this, just to recall this problem, we're looking at the mean age of graduate students at a university at most 31 years with a standard deviation of 2 years. A random sample of students, of 30 grad students, is taken. Sample mean is 32. The standard deviation is 3. Are the data significant? So we looked at the confidence intervals. We estimated those down here. But what we didn't do was estimate the exact position of the sample mean relative to the population mean. So for this one, you can see we have a formula to calculate z. And the reason we're doing z is because it's a large sample. Again, small samples, we're going to use the t distribution, similar formula. But when we know the overall population mean, we can include that in the equation. So that's what we're doing here. So we have the sample mean minus the overall population mean for the university. So it's going to be 32 minus 31, right? So B8 minus B7. So that's what we have here in the numerator. And in the denominator, we have the standard deviation divided by the square root of the sample size. So 30 was the sample size, and the standard deviation is 3. So here's the formula bringing those in, and when we complete the calculation, we get a z of 1.82, and we already looked at the critical values of z up here, right? So at the 95% level, it's 1.96. So 1.82 is smaller, right? So we fail to reject the null hypothesis of difference, right? So the sample of students is no different from should say the sample is no different from the rest of the university. There we go. All right, so that's the plain language conclusion. Same example here, but reducing the sample size down to 15 just to see what that does to our findings. And so here, again, we're calculating t, and we're looking at degrees of freedom of n minus 1, so 14. So same critical values of t, those still apply. We're still going to be comparing our results to those, right? So at the 95% level, we're going to be comparing to 1.76. The equation this time, we don't know. We do know the population mean, so it's again the same numerator as the z-test. But down here, it's just the square root of B6, the standard deviation. So it's B10, the sample size. Sorry, B10 is the standard deviation. You can see standard deviation divided by the square root of n. So standard deviation is 3 divided by the square root of 15. Right, so that's what we've got in the denominator. And when we complete the calculation of t, we get 1.29. And 1.29 is less than 1.36, which is the critical value of t at a 95% confidence level with degrees of freedom equal to 14. So we've, again, same conclusion actually. We fail to reject the null. And the plain language sample is no different than the rest of the university. This third example involves proportions. Once again, we're moving past confidence intervals down to the actual hypothesis test. And we use Z for this, and our analysis of proportions is going to be limited to large samples. It gets more complex when we're dealing with small sample proportions. So we've got this formula. So Z is a sample probability minus the population probability over the standard deviation of the population. And if we don't know population values, we can use some substitution here. So this problem, again, we were looking at whether 361 schoolmates at a college were less fearful of public speaking than the average for the rest of the country, which was 40%. From before, we estimated p to be 0.37, and then we also estimated the q value, which is 1 minus p. We already found our z critical values from the z table based on our level of confidence, and we already calculated standard error for the confidence interval. So let's look down here at the hypothesis test. So in the numerator, we have B9 minus B8, right? So we have the sample proportion minus the population proportion. And in the denominator, the square root of PQ times, P times Q divided by N. So what that looks like is the square root of B9 times B10 divided by 6. Let's just add some parentheses to make sure we've got the order of operations protected there. Didn't make any difference there. And then we complete the calculation by dividing the numerator into the denominator. Since it is a numerator and a denominator, I like to include the fraction line there by highlighting a border for that cell. And then, we're just dividing the numerator by the denominator to get our z value of negative 1.02. Since our critical value is 1.65, we can see it's smaller. And we fail to reject the null hypothesis of no difference. So her school is no different from the country regarding the proportion fearing public speaking, which was the same conclusion we drew when we were just looking at the confidence intervals. All right, thank you.